looks like he can't make up his mind what time it is. With his clock, watches, and calendar, he could well represent one of us in this world of ours as we try to keep track of the minutes, hours, days, and years. And the problem is, of course, there is nothing so constant as time. It keeps ticking away every second, every minute. We can never slow it down or make it stop. Even to relive an hour or a day. Or can we? Suppose we could fly in a jet faster than what the sun appears to be traveling across the sky, always keeping ahead of it as we would fly west around the earth. Could we make time stand still so that we would not grow any older? Or better yet, could we go back in time to relive our younger days once more? Interesting questions, aren't they? Perhaps together we can find some answers for them. This fellow seems to have found an answer, at least to waking up in the morning. He does what a lot of us do, use an alarm on a clock to alert our ears and tell our brain, hey, it's time to get up. But who is telling the clock what time it is? Who is telling the watch on your wrist or the clock on the wall what time it should be? You and I don't, but we are told by somebody somewhere. No, it's not this fellow, although he does have the right idea and is suggesting that you watch what he's watching, the motions of our Earth as it moves in space around our Mr. Sun. For here is the real beginning of what we call time in our world. Two important motions of our Earth, giving us two important units of time. First, the rotation of our Earth on its axis, giving us our 24-hour day. Secondly, our Earth revolving about Mr. Sun, giving us our year of 365 1/4 days. But what about that extra quarter of a day? Simple enough solution. Our friend says merely wait out 4 revolutions of our Earth around Mr. Sun, and then we'll have 4 1/4 days that we can add together and put as one full day at the end of February, calling this a leap year. Now we come out even for keeping track of the years. The only trouble is we're 4 years older, and we still haven't been able to stop Father Time. In fact, we keep getting older each day. Every time the Earth rotates once on its axis, we've added 24 hours to our lives. Starting from what hour? When does our new day begin? I'm betting that most of you are saying, why, midnight, of course. 1 second after midnight begins a new day. From one midnight to the next is known as a solar day. For keeping time, however, astronomers use what is called an average or mean solar day, one that is divided into 24 equal parts, so that the hour hand would move around twice in that period of time. So wherever you live on this Earth of ours, when your clock says midnight, it begins a new day for you. However, for the people who help make sure that our clocks are keeping time accurately, the most important time is not in the middle of the night, midnight, but rather in the middle of the day, 12 o'clock noon. That's the important moment, because that is when the sun, rising from the east, reaches its zenith, its highest point or position in the sky. We could actually call this moment the sun's meridian, because this word means midday or noon. Do you remember this word when working with longitude? We use the meridians marked as lines on maps and globes to help us measure longitude, don't we? The most important meridian is called the prime meridian, sometimes named the Greenwich meridian, because its pathway crosses the famous observatory at Greenwich, England. Suppose we could extend the Greenwich meridian directly upward, all the way across the sky as an imaginary line. Then the moment that the sun crosses this meridian, we would know that the sun is at its highest point or zenith, and that it is exactly 12 o'clock noon everywhere along the Greenwich meridian. Astronomers do this very thing. At noontime every day of the year, they can carefully check the sun's position according to the Greenwich meridian to set or reset the master clock of the world located at the observatory at Greenwich. But what about the time before or after this meridian? That's what this young fella is trying to figure out. The words anti-meridian and post-meridian. Well, we know now that the word meridian means midday or noon. Ante is a prefix meaning before, while post is a prefix meaning after. Before noon, after noon. In fact, take the beginning letters of these two words and you have AM, while the beginning letters of these two words give us PM. Now we're making progress. How many hours in this AM part of the day? 12 hours is correct. And in the PM part, another 12 hours. 12 and 12 gives us our 24-hour day, the time that it takes the Earth to rotate once on its axis. Astronomers check this 24-hour day at the Greenwich Meridian when the sun is at its zenith to make sure we're right on time. But this poor fellow doesn't live on the Greenwich Meridian. How will he know what time it is where he lives? Simple enough, says this young lady. Just divide up this world with 24 meridians and everything will work out just fine. All right, let's do as she suggests. It would be like dividing the world into 24 equal parts. How many degrees are there in any circle? Do you remember? 360 degrees is right. 360 degrees divided into 24 parts. There. Now we have our 24 parts. How many degrees are in each part? See if you can discover the answer. Between each line, there are 15 degrees, aren't there? Here on the globe, we've shown the same divisions. The meridians, 15 degrees apart, 24 meridians in all. And for every 15 degrees, a difference of 1 hour showing on the clock. Let's see it a different way. When it is 12 noon at the Greenwich Meridian, it is 11 a.m. 15 degrees west, anywhere along this meridian. 10 a.m. at 30 degrees west, 9 a.m. at 45 degrees west. Every 15 degrees shows a difference of 1 hour. Going east from the prime or Greenwich Meridian, the same thing happens, only it gets later by 1 hour intervals. Every 15 degrees. 1 p.m., 2 p.m., 3 p.m., and so forth. This old-timer thinks he's discovered something about all this. Let's see if you agree. Since the Earth spins or rotates from west to east, the time of day is always earlier to the west of wherever we are and is later to the east of our position on Earth. In this example, our position is on the 90-degree west meridian, and our watch says that it is 12 o'clock noon. Is it earlier or later than noon at point A, 105 degrees west? Earlier, actually 11 a.m. What time would it be at point B, which is 15 degrees east of where we are? 1 p.m. is correct. Would X and Y have the same time or not? Yes, because they are on the same meridian. These meridians then are very helpful in dividing up our 24-hour day into 24 different time zones. Whenever we travel west from one time zone to the next, we merely subtract 1 hour. We change our watch and make it 1 hour earlier. Going in the opposite direction or east, we would add 1 hour, changing our watch to 1 hour later. Here in the continental United States, there are 4 different standard time zones that we often hear referred to in radio and television programming. Eastern, Central, Mountain, and Pacific. Notice that these time zones do not follow closely the meridian lines. This is to avoid the confusion that would result if there were 2 different time zones running through the very same city. Imagine yourself in one zone, being in school at 9 a.m. by your watch and the school's clock, while your friend living 5 blocks west in a different time zone shows up 1 hour later, but showing 9 a.m. by his watch. Working hours, business operations, bus, rail, airplane schedules would all be confused. Hence, the lines have been purposely drawn along state boundaries or rivers outside of cities and towns where few people live, so that all the people living within the same zone will show the same time on their clocks and watches. He's saying we're forgetting something. And you know, we are. Alaska and Hawaii. They are both in the same standard time zone. But since both are a good distance west of the California coast, we often forget to include their zone with the other zones that cover our nation. Actually, the time in Alaska and Hawaii is 2 hours earlier than the time in California. If we keep going west from one time zone to the next, will the time keep getting earlier and earlier? Only up to a certain point. Or more correctly, only up to a certain line. A very important imaginary line that this person wants to bring to our attention. Because somewhere in one of the 24 time zones, there has to be a place that we begin a new day. And here it is, out in the middle of the Pacific Ocean, on the 108th degree meridian, halfway around the world from the Greenwich meridian. It even has an important sounding name, International Dateline. The word international is used because all the nations agree to use this imaginary line as the starting place for beginning a new day. How does it work? Well, suppose that it's Monday, 9 a.m. as we approach the date line by airplane or by ship. As soon as we cross the line, a new day begins. Not a new hour, but a new day. It was Monday, now it has suddenly become Tuesday. Same hour, 9 a.m. In other words, there is no hourly change in crossing the date line, only a change in the day. If you're traveling west, 1 day later. If you're traveling east, 1 day earlier. You think you got the concept? Let's see. Suppose your ship is at point B, Thursday, 3 p.m. What time and day is it at point A? Friday, 3 p.m. is right. A little practice with the date line and you'll catch on quickly. Find it here on your globe and trace its pathway over the surface. You'll notice that at several places, the date line cuts around island groups that happen to be directly in its pathway. This helps prevent having two different days being lived through at the very same time on the very same island, which of course would be very confusing to the islanders. Can we make time stand still or outrun it? No, time is relative to whatever we're doing and wherever we are on the surface of the earth. So instead of trying to outdo time, we really ought to be trying to understand it and use it wisely.